Hi, for today's class, we're going to be going over section 3.1, part B, number 30. So the question we have is, the hexadecimal numeration system is used in computer programming. It is a base 16 system and uses the symbols 0 through 9 and then A through F. We have to convert the following to base 10. So first, let's start with what we know. So we're given the question that we're using the hexadecimal system, and we have to find two different numbers and change them into base 10. So what we know is we're in base 16, and this means that they use numbers starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For us here, we use base 10. So that means this is where we stop. But for base 16, since we can't obviously put more than 9 in like a place value, they use letters. So for those, we'll use the A through F as given in the problem. So then after 9, we go A, B, C, D, E, F. There's a prettier F. So, just like in the base 10, we need to look at the place values. So for base 10, we don't normally talk about it. To get into the system so we know how we're going to work out this problem, let's look at the number 514. So here we know that this is the ones place, this is the tens, and this is the hundreds. So in other words, for the hundreds place, it can be written as a 10 squared place. So now let's compare it with another number, 1,151, which is the thousands place, just to get another perspective. That's also 10 cubed. So now if we think about this, in the base 16 problem, we have the ones place, and then since this is base 10, that's why we use 10, and then 10 squared, and then 10 cubed. So that's why for base 16, we're going to use 16, and then the next place value would be 16 squared, and then 16 cubed. So that's just kind of to get used to the problem and what we're going to be doing. So in our problem, for part A, we are given 864 base 16. So we're just going to work over here now, since we're out of room over there. So we have base 16 for 864. So 864 base 16. We don't really want to say as 864 actually, because this isn't the tens place, so it's just 864 base 16. So we know that there's 4 in the 16's place, and as we figured out over here, we now know that there's 6 in the 16 squared, and 8. Oh, I'm so sorry. This is actually the ones place. This would be the 16's, and this is the 16's place, because we can't forget about the ones. We always want to start with the ones place value. So we have 1 in the 4's, 6 in the 16's, and 8 in the 16 squared. So first we want to find out what 16 squared would be, so we know how many 8's there are in the 16 squared place. So that would be 256. So now we have, instead of 16 squared, 256. So just as if we were doing the problem 514 again, it would be, just to kind of get used to it in the base 10s, to figure this out, it's like saying 5 times the place value, which would be 100. So 5 times 100 plus 1 times 10 plus 4 times 1. So that's actually how we get 514. So now doing the same thing for this, we're going to get 8 times, as we figured out, 16 squared, 256, plus, now the however many are the 16's place, so then we get 6 times 16 plus 4 times 1. And if we do that, now we'll get 2,048 plus 6 times 16, 96, and then 4 times 1, 1. So now if we add all that up, we learn that 864 base 16 is then going to be 2,000 148. And then normally it's base 10, so then we won't have to write base 10, and that's 864 base 16 is 2,148 in the normal base 10 system. And that was part A. Now let's move over and do part B. And for part B, we are given, this one is where it gets tricky because now we get past the 9s and we have 2, C, D, E as our problem. So 2, C, D, E. So now is when these numbers, or letters actually, will start to come into place once we get past 0 through 9. So we're going to do the same thing with the place values. So we know it's the place value for E is going to be 1. And then we have D, which will be in the 16's place value, and C in the 16 squared, and 2 in the 16 cubed. So now we're going to write this a little easier to understand. So over here, if we kind of translate the A through F, we know that they'll actually end up being like 10, 11, 12, 13, 14, and 15. So since we're using C, D, and E, it ends up, we're going to use the 12, 13, and 14. So then if we come back over here, just to make it easier to write, we're going to write under it, and we'll just cross it out so we know what numbers we're actually working with, which was the 12, 13, and 14. And now we're going to do the same thing we did where we just multiply that many times this. So we knew this was 256, and then now we need the 16 cubed as well, which will end up being 4,096 for 16 cubed, 4096. And then we're going to multiply each number times that place value, and then add them all up, just like we did for part A. So we'll end up getting 2 times 4,096 plus 12 times 256, 256, plus 13 times 16, plus 14 times 1. And then once we add all that up, we'll end up getting 8,192 plus 12 times 256, which will be 3,072, plus 13 times 16, 208, plus 14. So here we took since it's base 16, we took the letters, changed them into the numbers value, and multiplied them times the place value of each digit. And adding that all up, we will get 11,486. So that's changing to CDE base. This was in base 16, just so that we keep everything straight, and changed it into the base 10 number. Thank you.